Right, we're live. Um, yeah, thanks guys. Thanks again for joining me on a Sunday afternoon and to Adam on a Sunday evening, being in Singapore, taking the time out to actually chat to us about his approaches and how he found the first case. I think I just want to say thank you, and we want to say well done from our side, because it was the first time ever that we had a South African as the local and global champion, actually beating all the international competitors as well. So I think that's very impressive and well done, man.
Awesome. Thanks for having me. Very exciting to be on one of these videos. When I first started competing in the Excel, the first time I gave it a go, I flunked badly. And then I went and I started watching the three of your videos, and that actually is what got me into Excel and got me through. So to now be on one of them is super cool. So thank you.
Thanks, man. No, it's great. I spoke to Dermot Early, who's the global champion. I spoke to him yesterday, and we've been talking ever since this case as well, because Dim is usually the one who knocks it out of the park. And I think the plan with this case was to make levels 1 through 4 accessible to most people who use Excel on a regular basis. And I think most people would be able to get at least level 3 out in half an hour's time if you're accustomed to a bit of Excel. But the rest of the case is actually very challenging, and I think we said that it was one of our most difficult levels 6 and 7 of all time. And I think we saw that in the points as well, because I think the highest points was actually between you and Jeremy Freelove, but I think you beat him on time. You beat him by a couple of seconds, and maybe 40 seconds or so. But it was 877 out of 1250, which is actually which actually equates to a quite a difficult case. But I think it was simple in its start, in getting you started, I guess. So I think without further ado, let's chat about the case. The case was called Tango, and I'm just going to share my screen and just maybe talk through it quickly. There's also, for the first time ever in the South African chapter, we have an intro video, and we're going to try and keep to that as well. And the intro video basically takes you through the basic rules and stuff, and it's actually so simple, and that's what I love about these cases, is when the rule set is simple, but you can actually get very complex. So yeah, Tango is a logic puzzle. It's a puzzle that you find on LinkedIn every day. I've been playing it non-stop for the past 217 days, and I wanted to do a case on it from the very beginning. So basically, you have a grid of 6 by 6 cells, and you have to complete the grid using suns and moons without guessing. And sometimes I do guess, because sometimes it's very difficult, but in this case, in this case, I don't think there's any of these that you had to guess. Um, and I think that's one of the things that I want to just make competitors aware of, is the fact that I think you could have done well solving a lot of this manually, without actually writing one formula. So that's another, I guess, tip is, if you see that you can go manual and you see that it's going to be too extreme to write a formula or a function, just do it manually. And I think a lot of people that did really well actually went manual. Yeah, so basically there's two core rules, and basically that is that you have to have the same number of suns and the same number of moons in the column in a row. And there's not, you're not allowed to have three in a row. So all of the cases, or all of the games in this case is actually solvable with just one solution, and that I made sure of as well. Um, right, but I think let's get into level 1. I don't know, maybe Adam, you want to talk us through how you approached this, like how did you, and you're welcome to share your screen as well, or I can navigate as well, up to you.
Sure, I'll give it a bash. So level one, again, I'm like you say, when I start off, I'm always quite aware of which levels the bonuses relate to. I think it's worth mentioning. So I would probably have, because this relates to level one, would have read this question at the same time. just to have in my mind, something what might come up. But yeah, I see that it is related to the answer, so then I would have gone straight into it. And yeah, the question shows that you need two suns and two moons in each question, and in each row, and we need to find out which is missing. So over here, I went and I copied the sun and the moon up on top here. I actually don't often name cells. Quite strangely, I know a lot of the good guys do. I'm quite used to just whacking F4 and logging cells. But over here, I used a pretty simple count ifs formula. So we're counting if in that range, how many moons there are and how many suns there are. And then saw pretty quickly that there was either ones or twos in each one. So there was never like a 3 and a 0. So then all I needed to do is X look up the 1 from this column and return either the sun or the moon. So you do that for the example, see it ties up, drag it down, and then often in these quizzes, they might give you a couple hints saying answer 2 is either this or that. So I always make sure I look for those. And in this case, pretty quick to eyeball and see that it is correct. And then just go and copy those, drag it down and copy them through.
Yeah, thanks. I think what's important to note in this case is the fact that this level is so simple that, like you said, you can eyeball it. And there were people who spent half an hour and got 0, and I don't know how, because you could have gotten at least this level out. And in this case, you didn't even have to count both. You could only count one, and then basically, so keep it simple. I think that's one of the things that I picked up early in my career, is try and keep it as simple as possible. And then I definitely did name my moon and my sun, because I could always refer to it back. So I think that was very helpful in level 1. Steyn, Jason, did you have anything that you wanted to add there?
Yeah, I also did the count if I took the number of moons less the number of suns, and then I would get either a 1 or -1, and then I just use a switch formula to put in the other symbol based on that.
Yeah, I think that's a good tip. Jason, did you want to add something?
No. I did pretty much exactly the same as Adam. X lookup 101. I did the countifs. I did name sun and moon as two name ranges. I think that was more helpful later on, so you didn't have to keep sort of coming back to find these cells and locking them. But yeah, otherwise very much the same.
Yeah, I think good point that you made there. The fact that you have the icons separated already is already a nice thing. So you could have just, and I think that's all I did, was I copied these two across to two other cells, but I could have just kept those and just called that moon and that one sun. Didn't even need to copy it across. And the way that I did it is I used the switch up front. So I switched moon to 0 and sun to 1, and I tried to keep to that logic. And because it's then binary, I could just do a sum of all of that. And if the sum was 2, then I knew I needed a moon. If the sum was 1, I needed a sun. So very similar approaches. But I think what was very helpful in later levels for me was taking everything to binary. And I'll show you some of what I did later on as well, in the binary rules. So level 2 was basically validating a 6-cell Tango row, and I think this was important because I also like my cases to actually help you build your thinking patterns, but also build a potential solution in the end. Because ultimately, for me, the best cases are those cases where you can actually build your solution as you go along. You can reuse some logic that you used in the previous levels, and you can actually get to hopefully level 6 and 7 in that way. But essentially, you had to validate, so you had to look at rules 1 and 2. In actual fact, the first level said that you have to apply rules 1 and 2, but in actual fact, you're just applying rule 1. You're just balancing. The second one, you have to test both, and there were various ways of doing this. The way that I did it was with a count if equals, where I just converted it back with the double dash into a number, so that I had a one for true and a 0 for false. And I basically just did a count if it's moon, count if it's sun, and if they equal to one another, then that meets the first criterion. And then the second one, I basically this was later on, so you wouldn't necessarily have time for that. But I just use a let function where I said, okay, concatenate for me the whole row. That's my row. A trip moon is a moon, 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 and a trip sun is a sun, sun, sun. And I basically said, if I don't have a trip moon by searching for trip moon in my Tango row, if I search and it is a number, and it's either a moon or a sun trip, then and I guess, yeah, just something to highlight is you can actually use multiplication logic then, if you have numbers. So if you put multiplied by, then 1 times 1 equals 1, but 1 times 0 or 0 times 1 is 0. So it's the multiplication logic then works across everything. Yeah, I don't know if there's better ways that you guys have done it, maybe.
Well, what I did is I did a sequence from there's 6 numbers, so there's 64 combinations. So I just generate the sequence of the 63 or 64, and then I tested all the combinations to see if they're valid or not, and then I was able to use that list of the valid and invalid ones still.
Okay.
So,
Yeah,
so you create like a master list, Steyn, like a master list
Yes.
of all the potential ones.
Yes.
Okay.
Yeah, so that would have helped you in level 5, because in level 5 you had to actually validate against all the possible combinations. So yeah, that could have helped you in level 5 definitely. Anything else to add, yeah, guys?
Yeah, I think the logic of building up a text string that you did, and potentially even a binary string, and then being able to search for 3 ones or 3 zeros within that string, I think is a really clever way to do it. Because I did it much more, say, less efficiently. I said, like, is 1 equal to 2 and is 1 equal to 3? Because that would mean that you've got 3 in a row. And then, like, had to do that 4 times, and then check if there were any trues, and then sum it up. So I obviously did it like just immediately, just trying to come up with a solve for level 2, not helpful for later on. And it proved to not be scalable the way that I'd done that. But the concatenation, and then looking for the 3 characters or 3 ones or 3 zeros, however you structured it, in the string, I think is a really clever way to think about it.
Yeah, I think I did it similarly initially, Jason, but then I didn't like the fact that I had to account for having spaces.
Yeah.
Two spaces on each side in order to test the logic. So I didn't like that, which is why I wanted to handle the string as a block, because I think that helped you later on in levels as well.
Yeah.
Can we move on to level 3? All right, so level 3 basically was asking us to complete a 4-cell row. So in this case, very similar to level 1. And in actual fact, I think Steyn said he could have used the exact same logic that he used in level 1. But then we added something later on, and this was an older version. Let me just go to the other version. Oh, there we go. So the older version didn't ask for the space or the gap where the gap sat, and that meant that level 3 wasn't actually more difficult than level 2, which is why we added the little logic to ask you where's the empty space and what symbol should you contain. So again, you could have used the same logic as in level 1, but now you also had to solve for where is the gap. And I think for a lot of novices, I think that's a very difficult thing to do. If you don't have ways of figuring that out, there might be very simple ways to do it, but that could actually make you stumble. And that's what's nice about these competitions and about these videos is we show you various ways of doing this, and then you're like, oh, that's actually clever, and you remember that and you keep it for later on. Maybe I don't know, Adam, if you want to tell us how you went about this one.
Yeah, sure. So right at the beginning, I did exactly as you said. I just reused level 1 to find what was missing. So counted the number of moons, counted the number of stars, and then X looked up the 1. And then you're right. So to find the gap, initially I think I went for an X lookup, and it gave me an issue. And what I landed up going for was the filter. So I filtered on the numbers 1, 2, 3, 4 when this was blank. So long as there's only one blank there, you're not going to get any spills. And that gave me the position each time of the blank. Then you just join the two together. And yeah, I actually found this. I stumbled a bit on level 2. I went about it more of a Jason style, where looking for counting the spaces and the gaps. And then this one, I think, got me back on track pretty quickly.
Oh, that's clever. I like the lookup, or the filter. Sorry, I like the filter. That's very similar to what I did, but I did an if is blank on it, and basically then said sum if it's blank. So I also referred to that 1, 2, 3, 4 at the top, which was very helpful because it already contained the number. But I basically said if it is blank, return the values. So it'll basically return false, false, 3, false, and then I did a sum of that, which would have given me 3. So that was how I did it. But I like the filter way better. Any other thoughts, guys?
Well, I did if is blank, then I changed it to another number, and then I did an X match to get the position of that new number. But I like this filter method much better.
Yeah, very cool.
Yeah, I did an X match is blank. Interesting. We all got slightly different ways on this one. I did an X match for true with a is blank. And then it was actually fairly straightforward formula. And X match gives you a position already, so you don't have to look up the 3, for example.
That's very clever.
Yeah.
So I think your method wins then, Jason, for me. I like that method. But yeah, so cool. So 4 different ways of doing this, right? We've been learning from each other and teaching each other how to do this, these kinds of things. But we've got 4 different solutions to a fairly intricate problem. But well, we basically shared 4 different ways of doing it. All right, so level 4. Let me just share my screen. Maybe you can just show us, Adam, while you're sharing level 4. Level 4 was basically completing a 6-cell row. So now we're building up on the logic of level 2, where you had to validate, but also levels 1 and 3, where you had to complete a 4-cell row. Now you basically have 2 gaps in the 6 cells, and you have to determine using rows rules 1 and 2 whether it should be a sun and a moon. And I think Jason said this the first time. I think for level 4, it might actually be quicker to do it manually, because you can visually, especially if you've practiced the game as well, you can visually quickly see, okay, we've got 2 suns in positions 1 and 2. The third one must be a moon, and then between 2 moons it has to be a sun. So it's the first answer is moon sun. So I think you could have done this in 10 seconds, maybe less, if you did it manually, where it could have taken you a minute or 2 if you had to write a function. And I saw that you had some interesting logic there, Adam. I don't know if you want to share your thinking patterns there.
Sure. So I actually went in between manual and automatic. I started off going for a formula, then realized, hold on a second, I can get this done pretty quickly with my eyes. So midway I actually changed through, but basically, again, counted how many suns, how many moons, and then I said how many are left of each of them, so just 3 minus. And then I said if the number of suns is 2, or the other one, so if they both 2, then I know what's left. So for something like this, where you've got a 2 and a 0, then you just say 2 of those and 0 of those. And so that worked.
You in the strings where you already had 3 of something, then you just immediately you need 2 of the other, so that eliminates half of the questions pretty quickly, and then you looked like you went sort of manual on the ones where you had to figure out what the order of them was.
Exactly. So I knew I couldn't just go, if I needed one of each, I couldn't just go sun moon, because then,
Yeah.
the order might not be right.
Yeah.
What I did here, which I've started to do, and I think it's lost me not doing this in the past, it's been a problem for me, is with my answer, I said that originally I said just make it equal to other. Then I went and I pasted the answers into the website before I even completed the other ones, because I've been stuck in the past where you're fighting the edge cases before you paste your answers in, and then the clock goes.
Yeah, that's clever. Yeah.
So now this time I'm not making that mistake again. I paste the answers in, and then I come back and I start working through the edge cases, and then you just repaste over.
That's a good
Interesting.
tip. You can get half the points on this round if you
Yes.
just
Yeah.
accept that the edge cases are not solved yet.
Yes.
Interesting that you say that, because I think what's interesting here as well is, if you thought about this, how many different variations of combinations can you get? You've got two of two, right? So you could have just created your permutations and just went like rand between 1 and 4, and you basically you do random, and then you go to logic. If you're like tight on time, I think you
Yes.
could have gotten at least 25% of the points easily by going like that as well. So I guess just a tip. I think it was you, Adam, so when I was reviewing some of the cases. I think it was you that actually, for level 7, I'm jumping ahead now. For level 7, I think you put the same answer throughout, and I think
Yes.
you got one or two right actually.
Really.
Yeah. So what's
Well
interesting is
done.
if you took bonus 4, I think, yeah.
Yeah.
So if you pasted the same answer. If you
I
take
pasted the
bonus
example answer
4.
actually.
Oh, yeah, okay. But if you take bonus 4, if you could have solved bonus 4, I think bonus D was actually asking for which pattern was used the most, and the likeliness, or the likelihood of that pattern being the most of the answers in level 6 and 7 is also quite high.
Yeah.
So you could have gotten quite a lot of points by just like doing that. So I guess just a tip for exam technique, when you're running out of time, you can actually get a lot of good marks or a lot of high marks with that logic. I think this was one of the cases where if you actually spent a lot of time on level 6, started with level 6, and got that out, and then went backwards and tried to do level 1, 2, 3 until you run out of time, I think you could have gotten top 10 in my mind. But you never know these things up front, right?
Another tip
Um,
that I do when
yeah.
it comes to guessing towards the end, sorry, just while we're there, we often see questions where it says what is the answer as a number, and if it's not a number, then just write no. You sometimes see that where you've got like a 17, 23, no, 15, 14, no. Then no often becomes the more common answer. So then when it comes to like guessing towards the end, I'll just complete them all as no. And I find I pick up quite a bit of extra points there. It's a lot easier to guess no than it is to guess a number.
I think
like
this
that.
competition rewards some strategic, like educated guesses.
Yeah.
And I think bonus E showed that on this case, which we'll get to.
Yeah. Some educated ingenuity guesses. So any other approaches worth mentioning on level 4, guys?
I think, I mean, I did mention that I think on this one, you could have done it manually more quickly, but then you shoot yourself in the foot for later. You're not starting to build out the logic. So if you're 5 minutes in at this point, it doesn't make sense to go manual, because you actually want to invest the time building out the logic that'll help you on 5 and 6. But if you're in a pinch, then manual here, I think, makes a lot of sense. For me, because I tried to solve this formulaically, level 4 for me was where I broke away into a new sheet and did like a proper solution build out model with a data table. So I jumped to that approach, I think probably earlier than some of you guys, because I just couldn't sort of, like, it felt too in depth to try and build out in a single row like how to solve the logic. I mean, you could do it, but like I just thought, I'm just going to break away, start building up my logic properly, and then I could scale that for levels 5 and 6.
Yeah, I think, I mean, I had the most time with this case than anyone, because I developed it. And I mean, I thought it would be quick, but it actually took me a lot more time than I thought, which is always the story that we tell. But I think just something worth mentioning, we spoke about this logic earlier, and that was my first kind of logic to try and solve this case, where I basically used ifs. So instead of nested ifs, I used the ifs function, and I basically said, well, so I tried to build all the logic into one nice function, but I couldn't solve the last edge case, which is why I moved to something different. But I guess it was just worth mentioning this. I also, while I was busy, I built a quick invert lambda, and I think that was quite helpful. Where if it's sun, make it moon. If it's moon, make it sun. And if you have a function like that, I mean, if you practiced, this is a very quick thing to create, and it's something that you can save and you can actually keep in your Lambda pocketbook or workbook, and use it for later cases or for future cases. But this was just basically doing a switch and saying, if it's moon, make it sun. If it's sun, make it moon. And that little function was actually quite helpful in the end. So just wanted to show that. Then I also wrote a little
Sorry,
lambda for
really,
two binary.
I'm going to interrupt you.
No, go for it.
That's a genius idea, because I built a 2D lookup table with a sun and a moon, and then a sun and a moon swapped, and then kept X looking up to do the other one.
Yeah.
If I just built like a simple sort of invert thing, that would have made a world of difference here.
Yeah, and the reason why I did that was because in my ifs, I saw that I was inverting 3 times. And I was like, yeah, no, I don't want to do that. So instead of pasting that function three times, I created a lambda, put it in a named range, had an invert function in my pocket. Then I also created a 2 binary where I just basically said sun is 1, moon is 0. And that helped me later on, and I'll show you guys. But that was also very helpful. And then I just created a 2 Tango, which is just the invert of that. Just to say if it's 1 and 0, take it back to Tango. And these 3 functions I could quickly create. And the nice thing is, these days, if you want to create a named range, if that function is there, you can actually go and say create named range, and it basically names it that already, and it puts the logic in for you automatically from an Excel perspective. So you don't even need to spend the time to do that. For those guys that are very serious about like taking this competition further, I just have to chat quickly about Eric Ohm's Excel robot, which is something that you can actually go and take a look at, and that also helps with this kind of logic where you can quickly take something into a lambda function, and out of a lambda function, etc. So I guess just putting it out there. But yeah, so I started off with this logic, but then I saw it didn't solve my edge cases. So I could solve every time where there were duplicates, or like 2 in a row, what's the third one? And then also if there's two on either side, what's the middle one? But it couldn't solve for the rest of the edge cases. And then I realized, you know what, the best way to solve this in my mind is to determine how many unique combinations are there, and this steps into level 5. How many unique combinations are there? I know that there's only one solution to this. So if I could figure out what combo it is, then I know the answer. And if you can take that data into a binary, so into zeros and ones, and you concatenate that, but you concatenate that with a question mark if it's blank, then you can actually use it as a wildcard lookup. And that way you can look up your function again. You can look up into the combinations. So I'm stepping into level 5 now, but if you could quickly figure out what the 14 different combinations are, and you take those into numbers, and you have question marks. It's a basic search function with wildcards, or it can be an X match with wildcards, and that way you can actually get your solution very, very quickly. So I guess that's a good intro into level 5. Can we go on to level 5, guys?
Yeah, this wildcard idea was like mind-blowing to me when you showed it to us a couple of days ago. Because to Steyn's point earlier, if you have a master list of what the valid combinations are, and in fact the bonus up front said there's 14 valid combinations of 6 strings here that work for Tango. You've got 14 things in the list that you can look for, and there's only one that will be valid in a given sort of setup. Then to do a wildcard search for that is like genius to me. It's like something I would never have thought of doing.
Yeah, so that's the, and I actually gave a tip, because I actually put the question marks in the string of the example. So I basically gave a tip away. But interestingly enough, what we found was that the length of, if I go length of moon, right? So I've saved moon now. It's actually 2 characters. And if I say length of sun, it's 2 characters. But interestingly enough, when I was developing the case initially, the one was actually just one character wide. And the Unicode value, if you go Unicode of these, sorry, no, I should have said Unicode of moon, and the Unicode of sun. Those are the unique characters, right? So, but those didn't change. But somewhere in moving over into this template, the length of one of those changed, because initially I actually gave the strings as concatenated. So the actual values of level 6, where you have a whole game, I put them as like concatenated, but then I realized it's going to be harsh, because guys are going to have to split them. If it's a sun split by 2, if it's a moon split by 1, and I was like, that's not going to work at all. That's why I was kind to actually split it out like this. But interestingly enough, you can't do the wildcard match successfully if you keep the icons as suns and moons. You have to convert them first, and I saw that a lot of people actually did that, where they either changed it into an M and an S for like sun and moon, or in my case, for instance, I used 1s and 0s because I love binary logic, and in the end, all I did was I took it to a 1 if it's a sun, I took it to a 0 if it's a moon, and I concatenated that. If it's blank, put a question mark, and with that, I could build out a string that I could then just do a search on. So I did a search of that value on the combos, and I took the sum of that, and that gave me the number of combinations, that it could have been. And to build out my combinations list, I basically just went into I think I went into one of the previous cases, yeah, the valid invalid cases. I did a unique lookup, or a unique list from level 2, and I just quickly checked which ones I needed. So to get this list quickly, I know that there's a lot of lambdas that you can find, like some of Bo's lambdas, Bo Riderbon. Some of his lambdas actually has permutation, like a permutation builder and things like that. I didn't have that. I always try and solve these things vanilla first. But I could quickly create my 14 different combinations like that. I created a concatenated version, then I created a binary version and a binary concatenated. And in the end, I think I called this one combos binary. And then I could look up that back to combos binary. And that was very helpful in level 6 and 7 as well. Yeah, I don't know if there's any other solutions that you guys found where you did it differently, or where you did it more simpler or more efficiently, I guess.
I'm happy to share my approach.
Yeah, please go.
Pretty similar. I changed to the sun and the moon to S&M. I came up with the seven combinations, and then to get the other 7, I just did an invert. If it's sun, make it moon, or if it's moon, make it sun. So that it helped a lot that you said there were only 14, because then I knew, all right, we can just get these out manually. And then I wanted to do a wildcard method, but for some reason, and I've only realized now why it didn't work, is I went star instead of question mark. And this whole time I actually forgot that it was supposed to be a question mark and not a star. So it didn't work for me in that method in the test.
Yeah, so I guess just to say, a star allows any number of characters, where a question mark allows 1. And that's the difference. Yeah.
Okay. So then what I did is, now that I had my 14, at each point I checked, does this combination match? So this is example 5, obviously using a data model. So here's 5. And I said, at each point in time, if it's a wild card, then that's true, that's cool. If it's not, does what I'm looking at equal what the example is? So as long as it met all of those, and what we need to find is we need to get a true across all of them for it to be a valid combination. So then I just counted how many trues there were, and then I just said, of all of those, how many have 6 trues? So perfectly fine, and then ran the data model across the examples.
So what you did was you actually created the wildcard lookup from like core principles, basically.
Yes.
Yeah. And I mean, this is great because this shows you the logic that you can follow, and if you can practice enough to do this quickly enough and get the points, perfect.
Yeah.
Because a lot of cases, in cases like this, if I'm under pressure and I'm doing it like this, and I try and do a concatenation in a wildcard and it doesn't work, I might give up. And then you need to know, okay, well, I've got another way to do this, and this is my other way. And I think that comes with experience and with practice, and I think you can attest to that as well, Adam. Great solution.
Just a random tip from what you've got on the screen there, Adam. If you say equals and of the row of trues and falses, it will only give you a true where they are all trues.
They're all trues, so nice.
So, I mean, as a sort of layer above your count if true, then you could do the lookup for a true, because there'd only be one true. So that's just a nice thing to know about using trues and falses. If you use the and function, I mean, I do this a lot in financial modeling, where you've got a row of different checks that are giving you trues and falses. And if you want all of them to be true, then you just say equals and the range. And if it gives you a true, it means everything's true. If it gives you a false, it means somewhere there's something wrong.
Nice one. Very cool.
Right. I think in the interest of time, let's move on to level 6. So Adam, maybe I think you did solve level 6, hey?
I don't think I would have gotten them all right, because I ran.
I think you mostly solved them, yes.
Yeah, so I can show you what I did. So obviously level 6, we now have many different rows, and then you told us which row to complete. So the first thing I did here was a wrap rows. So for those that don't know, if you've got a long string and you want to pull it up into a table, wrap rows will give you the first 6, then the next 6, and the next 6 underneath each other. Wrap cols will do columns. And it comes up a lot, right? In a lot of examples, these wrap rows and wrap cols is particularly useful. So then I just use an index function on this block here to pull up the row that you told us to look at. So if you leave the columns blank in the template, then it will just pull up the whole of the row that you've said to look at. So that's the row we're looking at over here. And then I just basically took my level 5 and pasted it right underneath, so we could see which ones are true and which ones are false. I didn't actually use this; it still wasn't working with the star. But I went for the exact same thing, where I went and I counted for the ones that were valid. Here, the problem was I knew that some of them would be valid. So in this example, there were 2 that were valid, but because I was sort of out of time. I think I actually did this. This was the last thing I did in the quiz. I'd gone back to the bonuses before that, which I think is quite useful, actually. I think my normal theory for bonuses is generally I go before the hards start. That's my time to go back to the bonuses. But I did this, and now I knew that I'd have a couple of possible solutions, but I knew that some of them might not work, going upwards into the columns. So I thought, in the interest of time, I'm just going to pick the first one, the first one that's got 6, and I just used that as my answer for all of them, hoping that if they all had 2 or 3, that I'd get some answers in there.
And I think interestingly enough, I think you solved. I think you maybe just didn't get points on 2 of them. I think you actually got 18 out of 20 correct using that logic. So amazing. That's very good. Maybe Steyn, Jason, I don't know if you've got other tips to give away on level 6, but this was a very difficult question because of the fact that it becomes a matrix, and because of the fact that you have to meet all criteria both directions. That makes it difficult. Steyn, I don't know if you have something to add there.
Well, I had a formula that checked the row and then returned the valid combination if there was only one. And then what I did is I ran it on all the rows and columns. And then I copied my table down a few. So on the first one, I got all the valid rows. And if there was only valid row, then on the second table, I put in the information from the valid rows to build sort of solve those rows. And then I did it on the columns and then on the rows. So then by the 5th table, I solved, in most cases, the table, and then I just did an index on where it was.
Oh, that's very cool. I think the funny thing is, I think Steyn, you said that the first 5 levels took you 20 minutes, and the last 2 took you 4 hours. Is that what you said?
Yeah, for the first time.
I remember him saying
Yeah.
that.
It's quite difficult.
I ended up in a very similar position to Adam, where actually, I mean, I had the luxury of time because we were testing the case. And so for this level 6, I sort of thought, like, how would I try and do this? And I initially started inverting or like rotating by 90 degrees so that I could apply my row logic to columns. But the thing that trips you up on this case is that the question says, give me row 1. So you've got one row to solve. But because there are 3 blanks in that row, if you've got 2 possible solutions for row 1, then you need to check 3 columns basically to see which one works, because that's where the 3 blanks are. And that was just starting to get exponentially big to me. So I kind of ended up where Adam ended up. I generated a list of the possible rows that could work. And then I just manually eyeballed, like, this one works, this one works, this one works. And I think sort of, Adam, the logic that you had, and I think why you scored a lot of the points here, is that a number of the 20 cases in this level only had one possible solution. And so pulling the first one is going to give you the right answer anyway. And then of the ones that had 2 or 3 or 4 possible solutions, you've got a 50/30/25% chance of taking the first one right anyway. And so that's just really good exam technique, I think, is just, just grab what's there. But for me, with the luxury of time, you could actually eyeball, so I generated a formula that said, if there's only one, fill it in. And this is very similar to your logic that you had on level 2 or 4, where it's like give me the answer if we know what the answer is. Otherwise, give me like a other or like a test manually word. And then I just went to those levels that had test manually and eyeballed, like, okay, I'm going to take the second row because that works, because I can see that column works. And so a combination of formula driven for the easy answers versus manual to get the rest out worked for me. But I mean, to get this done formulaically was not a straightforward thing to do.
Well, interestingly enough, the level 6 initially, especially the first couple of them, you'll see that there's very little blanks. There's actually only a handful of blanks. So the chances of having more than one solution per row was actually a lot lower than in level 7, for instance. So basically, in the end, what I did, and again, I also had the privilege of having a lot of time to build this out. But initially, Copilot and I built a function to solve this because I had to test it as well, right? So
Yeah, just to
I
be clear,
wouldn't
that
have
was
been
for
allowed.
testing purposes.
Yeah. I wouldn't have been allowed to use that in like solving the case. And like I said, we actually built in, and I'll share that a bit later because I don't want to give away all the tricks. But I built in ways of testing whether people used AI or not, and also perhaps also counteracting them using AI. But yeah, I also did very similar to Adam. Did a wrap rows, and also brought the row index across. And then, I mean, I used various different ways of doing this, but in the end, I again used my combos binary, converted everything into binary, and then basically just check if it fits the row and fits the column. So I tested the different combinations against each other, and basically iterated through that with Biro and Bicol lambdas. Um, but again, building out this logic in half an hour, I wouldn't have been able to do that. But I'm happy to share that. But basically, it's similar to what Steyn did, but just in a lambda function that could basically test the different combinations. But I mean, if you looked up this row back to combos, there's only one solution because there's only one gap. This one might have two or three solutions. Uh, we were asking for three. So row 3 in 102 only has one solution. So that this should have taken you 5 seconds or 2 seconds if you did it manually. And I think a lot of people did it manually and they got it out. But it is nice to test yourself afterwards, and I challenge everyone, go test yourself afterwards, see if you can write a lambda. Try and figure it out. Spend time with Copilot even. Sorry, I use Copilot because we're restricted to only Copilot, but I Copilot helped me a lot and helps me. And you can basically say, okay, let's build it by iteration and teach me how while we build it. Don't just give me the answer. And you can actually learn a lot through this, right? So yes, you can solve it with a lambda. And again, I just did a data table similar to what Adam did, and yeah, this was just me again testing out binary logic and stuff. But this was for bonus D as well to determine the how well, um, which combination was used the most. And the cool thing is, if you use a data table, you can actually put your all your combinations. So this is just the transposed binary combos, and you can put all your combinations down there. Do one data table to count each different. So this was counting the different combinations. I think this was splitting out and counting the different combinations. But I just counted the number of times each of these occurred in each of the rows, and sum them up in the end, and determined that that's the combination. And because I've got the two because I've got the what do you call it, two binary and back to Tango, I could use the two bin and two binary and two Tango functions to quickly convert this back. But yeah, that was basically to solve bonus D, I think, as well. Maybe we should chat about the bonuses. I don't know. Can we step onto the bonuses, guys? Just in the interest of time.
Yeah.
Yeah, so bonus A was asking how many moons appear in the answers to level 1. Very simple. If you've got the answers to level 1, you basically just count if the answers to level 1 is a moon. Okay, very simple. The second question, and interestingly enough, a lot of people got 400 and something, and they basically were counting moons instead of suns. So very important to read the question. But how many suns appear in the question areas across all levels 1 to 6? So exclude all examples, other sheets, and answer cells. This sheet only. So we made it very clear. We always try and read this 100 times and make sure that we make it very clear. But for bonus for bonus B, what I just did was I did a 2-column, so to get it into 1 column, and I did a V stack of each of the question areas. So this is a bit manual, but I basically just did a V stack of each of the question areas quickly, put it into a column, and then important is that this comma 3 in the 2-col ignores blanks, errors, etc. Because if I don't have that, I'm going to have a lot of noise in my column, and then I can just basically count if again. So interestingly enough, I used sum of switch, but I could have just done a count if it's sons. Bonus A and B, did you guys have any interesting other methods of doing this?
Same for me.
Same.
Very important is to link your answers back, right? Because if someone is going to review your work, they should not think that you cheated. Okay, so I saw a lot of people while I was reviewing cases. I saw a lot of people not do that. So a good example, a good exam technique is like for bonus B, I just basically built this, put a function in, and then just link that back. So very simple, very quick. It doesn't really take more time. But that's helpful. Then bonus C was quite a
In
cool, and I
change, you
think
have
this
the
was.
old answer there. Renier,
Oh,
you have the
sorry.
old answers there.
Yeah, sorry. Let me just go to my other. So I did this over various versions, so apologies for that. So a very cool question on bonus C, and this was Jason's idea. So the question is on the Tango board sheet. Which column is the widest? Your answer should just be the column letters. Hint, you may not be able to see it off the bat. Okay, so basically if you go to the Tango board, okay, so this was initially hidden. So, and I think a lot of people don't even know about this, that you can actually hide everything around your block. But you had to find the column that is the widest. Now, there's various ways of doing this, and I mean, one of the ways that I would do this is holding the control button and just pressing to the right. But then I see, okay, I'm going to the far right, so nothing there. So maybe if there's something in there, and I actually put the something, I put it in the second row because I knew that some people would actually use that logic. But if you hold the control key and you press the right button, the right arrow, you find column MS, and it's an Easter egg within an Easter egg because MS is short for moon sun, and it basically said, "How's it, moon sun?" So yeah, just a little bit of South African humor there. But yeah, this was the widest column in that sheet. And interestingly enough, as well, if you went into the name manager, you would have seen that there's a name widest column, and that refers to Tango board MS. So you could have found that without even looking at the Tango board. Adam, how did you find it?
I got a bit lucky actually because I never unhit the columns. I made them all a little bit wider. And then I thought, oh no, now I've made them all the same width.
Okay.
How am I going to go and find it? And then instead of control right, I don't know why, but I pushed control end. And
Oh, yeah,
control
yeah, yeah.
end will find the last
Yeah.
one, even if it's in a different row. And then I saw the house,
right.
then I saw the houses message, and I'm like, all right. And then I
Oh,
went,
genius.
and then
Yeah.
as I clicked on that house, I saw it in the top corner there. I saw it was in the name manager too. So if you just click on that house
Yeah.
itself,
Widest
then
column.
I saw
Yeah.
widest column. I'm like, all right, that's the one.
So you
That's genius.
yeah, so control home takes you to the first cell, and control end takes you to the last cell in the workbook. So yeah, cool trick. Love it. Well done.
Just so that people don't shout at us, like there is a way to do it with formulas, so that you don't
Yeah,
have
of
to
course.
look for the Easter eggs and stuff like that. So I used to test it. I used the cell function equals cell in that Tango sheet at the bottom equals cell. One of the options when you type equals cell is width. So you just double click on width, and then you give it the reference, comma of the give it the reference of the cell that you're in. And I shot that all the way to the end of the worksheet, and then just looked up the biggest number I could find, and that gave me the column reference. So there is there is a formula way to drive this thing, but yeah, it was a bit more of a joke, this one. Yeah.
Yeah. Interesting that what is it spilled to?
I don't know what the false means, to be honest. I just did take (1) of that.
Or you can do some as
Or
well.
some. Yeah.
Yeah,
I
so
did
just to
take
show
(1),
what Jason means is you can actually go and like copy that across if you wanted to. This is manual. That's not gonna
But
help.
if you just shoot that, just copy that and shoot it across to where the hazard is, and then you'll see that that is like not 2 or 8. It's like a big number.
Yeah. So that's 50. And I think it relates to pixels. Oh, no, it's just the number of the column width. So yeah. And then the method that Jason is talking about is using X lookup, and then you look up a very high number. So you can you look up a very high number, or trick from dim is you go 10 to the power of 9, for instance, right? That's very high. So it's a quick way to generate a very high number, and then your lookup array is your whole block, and then your return array can also can also be you can basically return a column number or something like that, or you can return an address if you wanted to. So you could go like address, sorry, not like that. You could go address of this whatever, and then the important thing is that your second to last, your match mode needs to be exact match or next smaller item. So -1 essentially. If it's that, then it's going to look for that very high number, but it's not going to find it, and it's going to look for the next smaller number, which will be the largest number in that range, and return the address of that. So there's a formula-driven way to do that, but just a fun Easter egg that brings in a bit of South African flavor as well. So we use "how's it" as a greeting. How's it? Okay, so okay, bonus D we already spoke of. So basically, the bonus D is that combination that I showed as part of the other solution, where I basically did that data table across, and I think that's well explained. And then bonus E, we'll get to now. This was a previous answer, so that was one of my testing versions. Interestingly enough, I also had a question in there: how many different combinations of completed 6x6 Tango boards comply with rules 1 and 2 only? But then I realized the only way to actually solve that question is using matrix math, and I was like, nobody's going to do that in half an hour. So we changed the question. That was also thanks to Jason. Jason kept it more simple like that. But yeah, and then bonus E was asking in the entire 100 by 100 grid of the Tango boards that follows rules 1 and 2, how many suns are in the green portion of the completed grid? So the important thing is that I think this is also so in my mind, I thought, and I still think there's a way to actually build a circular referenced function or formula, and I was very close to doing that, but then I ran out of time. But there's a formulaic way for you to say, if I know what is going on in this, if I'm testing this cell, if I know what's going on in this range as well as this range, if I can test that cell relative to its cousins, then I will be able to figure out what that character is. And if I can copy that logic across, and I switch on circular referencing, and I make sure that I've got enough iterations, I believe that there is a way to do this. And I haven't had time. I wanted to have done this already, but I believe that there is an iterative calculation that you can build, and I haven't been able to. So in the end, how I built this initially was I created a completed board, and then I took away 20% of everything. But interestingly enough, the answer to this is exactly half. So we took a block, and I think my initial block was was actually like this, for instance, right? I think it was a perfect square, and the answer was exactly half of it was the number of suns. But then I said, okay, let me just take a random rectangle, and the answer was again exactly half. And I was like, I'm just going to keep it like that. And Adam, your answer was genius, because you basically said, okay, how many rows do I have? Okay, 16 rows. How many columns do I have? Count the columns. 81. You could have gone, if you could have gone and selected the whole column, just put in like a number one, and then it would have told you like 81. And you could have gone like this and said, okay, make that number one, and that's 16. So Adam just went with his basic calculation and said 16 multiplied by 81 divided by 2, and that was the answer.
But I will say
Steyn.
it's not for all areas where it's 50-50. It sometimes go one or two
No,
into the one.
100%.
Yeah.
100%. It's most of the time it can be off by one or two, but interestingly enough, it was exactly half. And that was bonus E. I don't know if you guys have anything to add there.
I mean, I know we're short on time, but I was sort of partway to your iterative solution, but I did a sort of manual iteration version where I used logic with the rules from above to say if there's two suns to the left, for example, this has to be a moon, or two suns above, or two suns to the right, or two suns down, this has to be a moon, for example. And so I had a duplicate board going on the right hand side, and filled in as much as I could using just that logic. And then if I couldn't prove something, then leave it blank. And then I copied that board and pasted it back. And by pasting it back, you give yourself more information. And I think that's the unlock to this iterative solution that you're talking about. But then just getting it to iterate is going to take, big lambda.
Yeah.
And I know when we did the game of life, I did a similar approach for that last question where I just duplicated the boards a couple of times to get to the answer. And I think Dim and a couple of guys on their YouTube channels showed how you could actually build that into an iterative one cell solution using reduce or something like that. Yeah.
No, so there's a lambda that can solve this. I was close to figuring that out as well, but I just couldn't spend more time. But I mean, this is why we build these cases. We don't build the cases so that everything is solvable in half an hour. We want to challenge the Bows, we want to challenge the Dims and the Jeremy Freeloves and the Adam Jacobsons of the world to actually say, you know what, find a way. And I don't want people to say, yeah, like it's only a qualification round. It's going to be a simple case. It's going to be solvable. I don't want people to just get full marks all the time in 10 minutes time. I want them to feel challenged, and that's why we're building these cases to challenge each other as well. So yes, my intentions were not that you would be able to solve it fully in half an hour, but I wanted to reward someone who had the ingenuity to say, it could be half, so let's just try that answer, and that was magical.
Sorry, what I will say, just for the sake of the purists, is I think this bonus E, you do get to a point where it's not an exhaustive solution. I think you get left with something like 200 blank cells on the 10,000 grid that are not unique. It's ambiguous. It could be one or the other. And then you need to go and test one answer, and it would break eventually because it would result in you not having a fully complete grid, and then you'd have to go back and test the next solution. So this is not a completely unambiguous solution, but yeah, I think you've articulated the at least the principle behind what we were trying to do.
Yeah, I guess the sentiment behind it. Yes.
The sentiment.
Yeah. So I guess let me just touch on level 7. So level 7, for me, the best way to solve level 7 is to manually actually look at the cells, because it's actually, again, very quick to determine So a red cell or a pink cell is opposite of the blue, and blues are the same. So I wanted to make sure that I always gave you at least one. So the best way to do this, you could have created a copy of the sheet, and you could have then gone Control H, so find and replace, and basically make everything blank, find by format. So choose the format from the cell, and it basically takes a blue cell, and then it will basically replace that with, for instance, S for same and maybe D for different. What up to you, right? So that would be a quick way for you to determine which of the addresses were the same or different, and then one of them would have always had a value in them at least. So it wasn't like that. I didn't want to make it as obvious to say a blue is always a sun and a red is always a moon, but it's always different. So if this is red, then this must definitely be a moon. So the easiest way to do this is just to basically go and say, okay, well, those are moons. So Control Shift V to paste values, and those are suns. And then use your level 6 logic to solve the rest of it. That to me was the fastest and easiest way to do level 7. So yes, you can using a formula determine which of them need to be the same. If you have, you could build out the logic just to determine which ones are blues and reds, and then determine one of them must have a value. Based on that value, what are the rest of them? And then basically build your new block of logic and use the same logic as level 6 to solve it. That in my mind is the most effective way to do level 7. Because I also made sure that level 7, once you've filled in the blanks, it only has one solution each. So that I'm certain of as well. So it definitely then uses the same. You can apply the same logic as level 6 once you've solved that portion. Any other thoughts from you guys?
Didn't
All right.
get one, yeah.
Yeah. Okay. So, but yeah, thanks again, Adam, for joining us. It was a privilege having you with us. Thank you for taking out the time late night in Singapore. When are you coming back to South Africa, man?
I'll be back next week. Next
Okay.
week on the weekend.
you-
So I'll
just
do the following
be there.
competition online again within the 24-hour
Cool.
gap, which is very cool of you.
Yeah. No. Cool. But yeah, just make sure that you're in South Africa for the finals.
Absolutely.
But yeah, so the finals are on the 12th of September in Sandton, same venue as last time, and then the next qualification round is a case by Steyn this coming Thursday. So it's going to be interesting. Very, very different case than this. So very, very unique case. I think it's the first time we did a case like this. Sorry, Jason, you're muted. I can just see that you're saying something, but.
I was going to say, and it's much easier. It's like super easy.
Is it? Okay. So yeah, but yeah, keen to see how you guys go. Thank you again for taking the time out. I appreciate you guys. And yeah, we'll definitely see you at the finals then, Adam. You've definitely qualified just based on the first round. But yeah, it's been a privilege, and I hope you guys enjoyed Tango. I see that I've got a couple of people who actually now play the LinkedIn games daily as well. I don't miss one day. I love them. Yeah, Jason said he wants to get off his phone. Oh, he's trying to get more and more off his phone, and now I've introduced him to a bunch of games that he can play daily.
Well, thanks for being a great case, and Adam, well done.
Cool. Thanks, everyone. Thanks for having me. And yeah, looking forward to the next one.
Yeah, take care, guys. Cheers.
Cheers.